doing your independent practice, it is fairly involved today. The tools in the circle are side, 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 and side, angle, side. And follow me on my notes really quickly. We'll say triangles are similar for your notes, front row. Triangles are similar if all sides are proportional. Proportional. That's key. We went over this, I believe, last week as well. And then side, angle, side. I'm going to draw a diagram for you of a side, angle, side relationship. Think of it as a sandwich. We have one side, one angle, and one side that are similar in both triangles, but that angle has to be included in between those sides. If you would, follow me to your model problem. We're going to jump right in. So the model problem, skip the overtime time today. I want to jump right into the math or your model problem. I want you to write down a few things right now. For one, really big up top, I want you to write down triangle similarity. That is the name of this game for this week. Triangle similarity. And under your key concepts, I want you to write down AA. And AA is going to mean, in this context, if two angles are the same, the triangles are similar. If two angles are the same, the triangles are similar. Let's think about it. If two angles in a triangle are the same, then that third angle must be the same because they all add to 180. A little bit of logic there. So when doing similarities, the first step you're going to do is to name your triangles. Name your triangles. And you're going to name these consistently. Consistently, meaning the same way you name your first triangle is the same way you name the second triangle. For example, I'm going to name my first triangle, my small triangle, A, B, C. My vertex, then my right angle, then my adjacent angle. I named that triangle A, B, C. I'll name my second triangle A, D, E. Vertex, right angle, and then adjacent angle. So we have two triangles here. We have a smaller triangle And then we have a larger triangle. ABC and ADE. Question.
When you said do name them same, I thought they
No. Name them in the same way,
the
consistently.
same order?
Right.
Okay.
That's a good way to think about it, in the same order. Chelsea, mine's one side conversation. So you focus. So, we have our two triangles, and now we can go ahead and establish similarity. I know these are similar, if I sign for similar, because of AA theorem. They have two angles that are the same. My first angle that's the same. These two angles are the same. They both share 90 degrees. And the trick here is that they both share this vertex angle of 8. So I'll go ahead and circle all my angles that are the same. So I know ABC is similar to ADE because they have right angles and they both share that vertex of 8. So 2 was established similarity. They're not always similar. Don't jump right in. You got to establish similarity. And then we'll say number 3, use proportion to solve for missing sides. And what that looks like, it's somewhat tricky because you're doing that first triangle in reference to that second triangle. So what that looks like is I'm comparing this triangle to this triangle. So the sides I'm looking for, I'll say 3. They gave me 3, and they gave me x. So I'll say 3 over x is equal to the size of my larger triangle. Hold on. At first you may think it's 9 over 12, but this is one entire length of my triangle. So it would be 12 over 12. Quiet.
Oh, wait, what?
Don't hold out. I'm holding out. Raise your hand.
You know.
So too many voices? When we have questions, we raise our hands.
You got eyes on me in 3. Thank you, Demetrius. In 2. Thank you, Nature. And 1. If you have questions, I know it's complicated, but please raise your hand. I'll call on you. Thank you. So, question from Nigel.
So the second part, that don't make sense to me.
Right.
Because you said you're doing the whole line. So I mean, the first one would be included too.
Exactly. So this is the first triangle, but my second triangle is this entire length. So it's 9 plus 3. Question, Demetrius? One second. Let me finish it first. I appreciate you guys' attention though. That's a great job, great questions. So then I go ahead and I cross multiply. If I cross multiply, 12x is equal to 36. So I'll divide by 12. Divide by 12, x is equal to 3. I'll write here, nice and plain what I have to do, x equals 3. Hold on. Question, which was? want you guys to follow me to your guided practice. We're number 1 together, and number 2, I'll give you some freedom on that one. Mine's 1 tonight for a side conversation. So, guided practice. My first step is going to be to name my triangle. Name my triangle. Consistently in the same order. So triangle A, B, C, and triangle A, B, E. This is key, so you're not thrown off on your sides. Then I establish similarity. Well, using the AA postulate, I can establish similarity because for 2 points of what? How can I establish similarity in these 2 triangles? Chelsea. How many angles do I have that are similar?
I mean, 2.
Two. I'll give you that, Chelsea. My similar angles are going to be my right angles again. And my vertex angle, one more time. They have 2 angles in common with each other. So I establish similarity, step number 2. Then step number 3, I set it up. Now I just side conversation fix it up. So again, and I set it up. Remember, I'm doing this triangle in relation to my larger triangle. So let's do 10 over 6 is equal to 20 over x. Minus 1 called not, Sienna. Please raise your hand. I told you 2 times already. One more time is a referral. Again, eyes on me. And 3. Thank you, Nathan. 2. Thank you, Chelsea. And 1. When I'm talking, you guys are not talking. I'm hearing too many voices. Let's be level 0, silent and solo. If you have a question, please raise your hand. Chelsea.
So when I say it was 2 angles, how come it wasn't 3? Because you circled 3 angles.
These are the same angle. That's the same angle. I circled it twice almost. They have these angles in common. They have this angle in common. They only have 2 angles in common. Great question. So for this one, we're having trouble seeing the sides here. This is one side, this is one side. 10 is one side, 6 is one side. On my larger triangle, 20 is one side, and this is one side, x is one side. So it looks like 10 over 6 is equal to 20 over x. Our biggest trick here is adding these together. So when I cross multiply, the first thing I do is go ahead and just reduce this fraction down, divide by 2.5, 5 over 3 equals 20 over x. I'll do 5 times x, I will get 5x equals to 60. Divide by 5, I'll get something like x is equal to 12. I want you all to try number 2 by yourselves. I'll give you a minute and a half, silent and solo, level 0, go.